Our TCO is so good that even when the competitors' chips are free, it's not cheap enough. In the last 10 years, we reduced the cost of computing by 1 million times. The cost of deep learning by 1 million times. If we could reduce the marginal cost of computing down to approximately zero, we might use it to do something insanely amazing. Large language models. To literally extract all of digital human knowledge from the internet and put it into a computer and let it go figure out what the knowledge is. That idea of scraping the entire internet and putting it in one computer and let the computer figure out what the program is an insane concept. But you wouldn't ever consider doing it unless the marginal cost of computing was zero. We made that breakthrough. And now we've enabled this new way of doing software. Imagine, for all the people that are still new to artificial intelligence, we've figured out how to use a computer to understand the meaning, not the pattern, but the meaning of almost all digital knowledge. And anything you can digitize, we can understand the meaning. So let me give you an example. Gene sequencing is digitizing genes. But now with large language models, we can go learn the meaning of that gene. We can understand what's the meaning of a cell. A whole bunch of genes that are connected together. And so this is, from a computer's perspective, no different than a whole page of words, and you asked it to summarize. What did it say? Summarize it for me. What's the meaning? This is no different than a long page of genes. What's the meaning of that? Big, long page of proteins. What's the meaning of that? That AI, which was enabled by this new form of computing we call accelerated computing that took 3 decades to do, is probably the single greatest invention of the technology industry. This will likely be the most important thing of the 21st century.
The GPU chip that is behind artificial intelligence right now is your H100, and I know you're introducing an H200. And I think I read that you plan to upgrade that each year. And so could you think ahead 5 years, March 2029, you're introducing the H700.
Right.
What will it allow us to do that we can't do now?
Let me first say something about the chip that John just described. As we say a chip, all of you in the audience probably, you imagine there's a chip kind of like, like this. The chip that John just described weighs 70 pounds. It consists of 35,000 parts. 8 of those parts came from TSMC. That one chip replaces a data center of old CPUs like this into one computer. The savings of that one computer is incredible, and yet it's the most expensive computer the world's ever seen. It's $250,000 per chip. We sell the world's first $250,000 chip. But the system that it replaced, the cables alone cost more than the chip, this H100. The cables of connecting all those old computers. That's the incredible thing that we did. We took this entire data center, we shrunk it into this one chip. The way that this chip works, it works not just at the chip level, but it works at the chip level and the algorithm level and the data center level. It doesn't do all of its work by itself. It works as a team. And so you connect a whole bunch of these things together, and networking is part of it, and it computes at data center scales. And together, what's going to happen in the next 10 years, say, John, we'll increase the computational capability for deep learning by another 1 million times. What happens when you do that? Today, we kind of learn, and then we apply it. We go train, inference. We learn, and we apply it. In the future, we'll have continuous learning. The training process and the inference process, the training process and the deployment process, application process will just become one. Well, that's exactly what we do. We don't have between now and 7 o'clock in the morning, I'm going to be doing my learning, and then after that, I'll just be doing inference. You're learning and inferencing all the time. And that reinforcement learning loop will be continuous. And that reinforcement learning will be grounded with real-world data through interaction, as well as synthetically generated data that we're creating in real time. So this computer will be imagining all the time. it'll do synthetic data generation, it'll do reinforcement learning, it'll continue to be grounded by real-world experiences, it'll imagine some things, it'll test it with real-world experience, it'll be grounded by that, and that entire loop is just one giant loop. That's what happens when you can compute for a million times cheaper than today. And so as I'm saying this, notice what's at the core of it. When you can drive the marginal cost of computing down to zero, then there are many new ways of doing something you're willing to do. This is no different than I'm willing to go further places because the marginal cost of transportation has gone to zero. I can fly from here to New York relatively cheaply. If it would have taken a month, I'll probably never go. And so it's exactly the same in transportation and just about everything that we do. And so we're going to take the marginal cost of computing down to approximately zero. As a result, we'll do a lot more computation.
As you probably know, there have been some recent stories that Nvidia will face more competition in the inference market than it has in the training market. But what you're saying is it's actually going to be one market, I think. Is there going to be a separate training chip market and inference chip market? Or it sounds like you're going to be continuously training and switching to inference, maybe within one chip. I don't know. Why don't you explain some more?
Today, whenever you prompt an AI, it could be ChatGPT or it could be Copilot. Whenever you're prompting, it's doing inference. So it's generating information for you. Whenever you do that, what's behind it, 100% of them, is NVIDIA's GPUs. And so NVIDIA's, most of the time you engage our platforms are when you're inferencing. And so 100% of the world's inferencing today is NVIDIA. Now, is inferencing hard or easy? The reason why people are picking on inference is when you look at training,